let's continue our review of the for the Unit 4 lecture exam in Introduction to Astronomy, and we want to talk about why do galaxies look different. And so the first reason is because of the way that they spin. Another name for this would be angular momentum. So if a initial galaxy is spinning slowly, then it's going to tend to form a more spherical shape. If it is spinning faster, then as it collapses, it's going to spin even faster, and it's going to collapse into a disk the same way that a solar system does. Okay, then the second reason that a galaxy could have a different shape has to do with its density. And so galaxies have thermal gas pressure the same way that solar systems do. And if you have a lot of thermal gas pressure, that's a bad thing, because that's going to be pushing material outwards. But we want it to collapse. So one way of getting rid of that thermal gas pressure is if you have a dense galaxy. So if you have a high density galaxy, then that means the heat can be conducted away from and out of the galaxy. That cools the galaxy down, which means that there's less thermal gas pressure. And so now that means that stars will form before they have a chance to make a disk. And so this then is going to be a spherical galaxy. If, on the other hand, you have a low density cloud, then that means that stars are going to form slower, and then those stars, as they form, are going to have enough time to collect on the disk, and then you are going to have a spiral galaxy as a result of that. Okay, then one of the reasons why you have irregular galaxies is because they're just so small. The smaller a galaxy is, the less gravity it's going to have. And so that means it's going to be harder to pull it in and turn it into a particular kind of structure. Okay, galaxies collide quite often. And so as galaxies collide, they can change their shapes. So it all depends on what kinds of galaxies were colliding. Were they two spherical galaxies that collided? Was one of them a spherical galaxy and then the other one was an elliptical galaxy? And then it might also depend on how did they collide. Was it a direct hit or was it a glancing blow? So depending on the collision, you can end up with different kinds of galaxies after the collision. Okay, then we also talked about energy output of galaxies. So that you had radio galaxies, which produce radio waves, and then you had Seyferts that could produce ultraviolet and X-rays. Then you had blazars that produced gamma rays, and then you had quasars, which produced all sorts of different kinds of radiation. You need to know that the quasars are the brightest objects in the universe. They're so bright that we can see them up to 10 billion light years away. Now that's a clue, because if they're 10 billion light years away, we're seeing them as they existed 10 billion years ago when they were young and they had a lot of gas. So if they have a lot of gas, that means they're making a lot of stars, which means they're giving off a lot of energy. Well, all of these different kinds of galaxies can be related with black holes. So as material falls onto a black hole from the accretion disk, it is going to give off tremendous amounts of energy. And then that energy can be channeled through the magnetic field of that black hole. So we think that most galaxies have a supermassive black hole in their middle. Okay, and then the supermassive black hole is emitting lots of energy. So if you have a supermassive black hole, so let's say that's the singularity, okay, then it's got this thing that surrounds it, which is called the accretion disk, which is the material that's going around and around faster and faster and giving off radiation. Okay, then it has the magnetic field that channels that radiation and shoots it off. Okay, and then the regular part of the galaxy is way out here. So this is a very, very small part of the galaxy, but it's very, very important. Okay, then if the Earth happens to be located out here somewhere, and if you're looking in this direction, you're going to see these two magnetic jets. And so you're going to see a radio galaxy. But on the other hand, if you are looking in this direction, so let's say the Earth is over here, and you're looking at this galaxy, and you're looking down the barrel of the magnetic field, then you're going to see a blazar. And then if you're looking in this direction, you're going to see yet a different kind of galaxy. So we think that all active galaxies, galaxies that are giving off lots of different kinds of radiation, are actually basically the same kind of galaxy, but we're looking at it from different viewpoints. Okay, then let's take one more break, and when we come back, we're going to look at larger structures in our universe.